Yeah.
Okay. All right. Good evening, everyone. Thank you for coming onto this session on our Excel series. So today we'll be talking about basic statistics that are essential for a data analyst to know. So what's the importance of learning statistics, or what's the usefulness of statistics as a data analyst? You need the knowledge of statistics for your data interpretation, okay? When you analyze your data, you need to be able to analyze, you need to be able to interpret and make draw insight and make conclusions from your findings. You need your knowledge of statistics for data validation, pattern recognition, and the risk assessment. So statistics and data analysis, data analytics, it works hand in hand. It's a knowledge that you must have. So in statistics, we have two branches. We have the descriptive statistics.
Mr. Bing, I can't hear anything. Good evening.
Hello. Thank you for joining, Mr. Paul. Can you hear me now?
Yes.
Hello, can you hear? All right, thank you. So, like I was saying, I said there are two main branches of statistics. We have the descriptive and the inferential. So descriptive statistics is the one that looks at it, just like the name, like it's describing your data. Just want to look at, explore it, look at it, the data. So that's when we have the measure of a location, which is also known as the measure of central tendency. And we have the measure of variability. So the main ones are the mean, median, and mode. We have the percentile too, the quartiles, but the main ones are the mean, median, and mode. So for the measure of variability, that's also known as a measure of dispersion. We have standard deviation, range, variance, and the like. So it depends on the report. If your data is normally distributed, what you'll be reporting is the mean. It's the mean. But when you have something like a data that is not normally distributed, that's when we look at median. Because at times when you have outliers in your data, it affects the mean. So in that case, you just report the median. So measure of variability, it now tells you like the difference, how all these values, how they differ from the ones in the mean, from the mean and the median. So it just tells you the variability in your data. That's the standard deviation, the variance, and the whole. So let's now move to inferential statistics. This is the main one. What does inferential statistics mean? It means you have a sample, you've done analysis on it. So you want to So you want to draw the results that you've gotten. You want to generalize it on the whole population. You can get data from the whole population. That is why we do sampling. Get just a small part of the population, carry out our research, and analyze the data we get from it, and use that data, that result, to make inference of the whole population. So to do that, our data has to be a true representative of the population. If it is not, we are going to be making a false generalization of the whole population. So the process of inferential statistics goes about from probability to sampling, hypothesis testing. And after you've tested and you see if the null hypothesis, okay. Can you see hear me? I think there's someone talking in the background.
I'm going to mute them. If you know that you are in a noisy place, then you mute yourself now. Please continue, please.
All right, thank you. Yes, I was saying the process of inferential statistics. Inferential statistics is when you try to draw results from a sample and use it to generalize for the whole population. Okay, when we look at the descriptive is just when you have a set of data like a sample and you look at the mean and say, okay, this is the average sales this company has made for this month. But when you now want to make like inferential, you want to use that statistics that you have to generalize about the whole, okay, let's say you're talking about a manufacturing company. So you want to say, oh, in this state or in this country, this is the average sales manufacturing companies make. So that means it's from that data that it goes from one manufacturing company that you want to use to generalize for all the manufacturing companies that exist. So that means that manufacturing company that you are using as your case study must be a true representative of the whole manufacturing company. Interesting. So, like I said, yes, this is the process. It goes from probability, sampling, hypothesis testing, then down to making your conclusion. That's with the differential statistics. So now let's take the step one after the other. So let's look at probability now. There's no, we'll be talking about statistics. I won't talk about probability. So it goes down to this is just a little explanation. So coin toss, yes. When you toss it, it's always a fair, because if it's not fair, probably it's dented. The probability of getting a head might be higher than probability of getting a tail. But if it is a fair one, there's no dent anywhere. It's a fair coin. That's what we mean by fair. It's not like it's a faulty coin or it's bent to one side. Okay, when you have a fair coin, that the probability of getting a head is the same as the probability of getting a tail. That's a fair coin. So I will sign when I share these slides, we can try our hands on this, but we need to mention probability. We all know the formula of probability. The number of the possibility of that outcome over the total number of possible outcome. That's a formula for probability. Okay. So the first question you're saying, if a fair coin is tossed, what is the probability of getting a head? There are two possible outcomes when you toss a coin. It's either you get a head or a tail. So the probability of getting head is 1/2 if it is tossed once. But the second question is saying if it is tossed 3 times. So it's going to be 1/2. It's 1/2 times 1/2 times 1/2. So that's the probability of getting. Okay, no, it says at least 2 heads. Okay, don't let me take much about. We can talk about this later. But once you know the probability of getting a head is 1/2, probability of getting a tail is 1/2. And probability does that is when you say probability A or B, head or tail, is going to be union. That's addition. But if it is A intersection, that is A and B, that's going to be multiplication. Okay, when it's or is addition, when it's and is multiplication.
Hello,
So
Mariam.
Hello, yeah?
Yeah, please, sorry to cut you. I want to say something to everybody. Please, if you know that your background is very noisy, please just mute yourself. It's not fair. We are recording this video and it will be on YouTube. Come on now, guys. Please continue.
All right, thank you, Brenda. Yeah, I was just trying to explain the basics of the probability. So when you have a fair outcome of a die from 1, 2, 3 up to 6. So when you roll a die, what's the probability of getting a particular number? That's 1/6. So we can try our hands on these questions later. Yeah, card probability 52. Yeah, this is just an so you know the number of things that the standard Descartes has. Let me move on to the sampling methods. Yes, we have probability sampling distribution and non-probability sampling distribution. From the word probability, we have said probability is the occurrence of a chance, the probability that something is likely to occur, the likelihood of something occurring, that's probability. So for probability sampling methods, it means the method you use to take your sample, to take your data, gives an equal chance to everybody. It's not like you're choosing this or not choosing this. Everybody in the population has a chance of being selected as your sample, being included in your sample. So we now have different kind of probability sampling methods. We have the simple random sampling. Simple random sampling is when you have population and you do a random sampling. There are different ways to do random sampling. You can use a random number generator. So it's just going to give you a set of unknown numbers. The numbers are going to be generated randomly. So for every number you pick, you're going to pick that position from your population. Okay. For stratified sampling, it's talking about you have a population and you group it into subgroups or stratas. Okay, so those strata is like, okay, let me give an example. Let's say you want to do a survey, okay, a survey on yes, you want to talk about politics in Nigeria, okay. So we have 36 states in Nigeria plus a FCT. So you want each state to be represented in your sample. So each state now can serve as a strata. So you now want to pick, okay, from Oyo State, I want to pick this number. From Lagos State, I'm going to pick this number. So those states are the strata in your population now. So you want to give each state equal probability, equal chance of being in your data. That's stratified sampling. So the data that you have, the population that you have, that will determine the sampling method you are going to implement, okay? For systematic sampling, you can have you have a whole chunk of data and you don't want to analyze everything. You need to pick just out of it. You can use the systematic. Systematic is you have a system of picking, okay? You pick a position, a particular position. Let's say the whole thing I have, let's say, okay, yes, I have 1,000 employees in a company and I don't want to interview everybody. I want to carry out like a survey to check their performance or what they feel about the increment, the salary increment or something, okay? So I can't interview all the employees in the organization. So I can do a systematic random sampling, whereby probably I have the list of all employees, okay? It can be alphabetically. So I can pick, okay, let's say I have 1,000 employees, yes, in the organization. So, and I need just 50 people for my sample, for my data to analyze. So I can pick, so it's going to be, the formula for this systematic is N divided by a small n. My capital N is the total population now, which is a total of 1,000 people in the organization. And what I'm interested in is 50. So it's going to be like 1,000 divided by 50. So I'm going to choose every 28th, that's 20 years. I'll choose every 28th person on that list of 1,000 people that I have. So anybody that falls on the number 28, 48, 68, it goes on and on. So if I do that, I'm going to have a total number of 50 people. So that's how systematic sampling works. For stratified, that is just like combining stratified and simple random sampling. Yes, like I explained, I use the example of a state, yes. So if you want to do a stratified random sampling, after going to your state, you're not just going to pick anybody in your state. You're going to you look at everybody in your state and give everybody in that state an equal chance of being picked again. It's not that, okay, because I'm in Oyo, I'll just take 5 people and go. No, you're going to look at, let's say you have 1,000 people there. You're going to look at it. How will I pick here? How will I give this or everyone here an equal chance of being picked? So after you have done a stratified sampling, you're going to do like a simple random sampling in each stratum. Yes. So for cluster is basically for nothing for rare or when you have, yes, let me give an example of that. When let's say I want to do a survey looking at Southwest, okay, also people in Southwest. Where do we find outside people in Southwest majorly? Is in those Sabo areas. So I don't need to go to the whole population and start searching for them. I know where they are based. So if I go to the Sabo in this particular area, I will see outside people. So that Sabo is a cluster on its own. So that means I'm doing a cluster sampling. I'm not going to be looking at other people who are not in that Sabo area. So I have where I'm going because I know this is where they are clustered. So most times it's usually the probability sampling method that we are interested in, because when you've selected your sample using a probability sampling method, you can make a generalization of the whole population. But if it's not probability, it won't be a true representative of your population, in the sense that, okay, let's say I want to carry out a survey and I need people between the ages of 30, okay, no, reproductive age now, let's say 15, women between 15 to 49 years. Okay, and I go to secondary school. The secondary school has a fixed age already. So I'm doing a convenience, it's not a random sampling. I can't get someone except I'm interviewing the teachers. But if I'm interested in only the students, I might not be, I won't, it's not if I might not be, I won't be getting, there will be a certain age that I will be limited to. Okay. So convenience sampling, we have convenience sampling, we have snowballing, yes. We use all these, they have their own usage too, because there are times that you might want to do surveys that the whole population are not in your inclusion criteria. They are not your point of interest. Let's say, for example, you're looking for smokers, or you're looking for, okay, let me say weed smokers, or those who inject, okay? You can't see them around. It's when you know someone, the person will now tell, they all know themselves. So they bring, or you are interested in doing a survey for sex workers, okay? All these are shower people. You won't find them in one place. It's one person that will tell another person so that they will get included. That kind of sampling is called snowballing. One will bring another, like a referrer. So that's basically sampling method. We should mention this. We have to mention this because it's all in line, like it's a process of our inferential statistics. If our sampling is not well done, whatever will be, after doing an hypothesis testing, the inference we'll be making will not be a true representation of our population. Yeah. So now to probability distribution. After our data is going to have a distribution, is going to follow. Okay, we have the discrete and the continuous. Example of the discrete, from the word discrete, it means the ones that are in counts that are not continuous. How do I explain this? Okay, the ones that are in whole, like the ones that are in whole number. Okay, yes, the outcomes are distinct. That's for discrete. But for continuous, it varies. It's included in an interval. Yes. So for discrete now, we have the Bernoulli. Bernoulli is when you have one trial, just one trial, one experiment is being done. Like if I want to break, okay, I want to break an egg. What's the probability of this egg being bad or is still good? Okay. If I break that egg, I have just two occurrences, right? It's either the egg is good or is bad. So once I break the egg, there's no going back. I can't like say I want to conduct another experiment on that same egg. No, it's not possible. I have to pick another egg. So Bernoulli is when you have just one trial. Okay, one trial that you can do. You can't do a multiple number of trials. So when you have multiple number of trials, that's when we have binomial. Because this we can actually go in depth into all these distributions later, but I just need to mention them so that you get just the basics of it and have a little understanding. So for continuous distribution, we have the normal. Yes, the normal is from the word normal. We all believe when we have a data set, it should follow a normal distribution. Okay, normal distribution. That is because normal it's concerned with most parametric statistics. That's when we have the correlation, the linear regression, and all sorts. So let's move on to explore. We all do this. Explore EDA. I want to do EDA. What is EDA? What is the importance of EDA? Just like I mentioned earlier, that descriptive, right? Just to look at the pattern in your data. Check it. What is the relationship in the data? How is it aligned? What is the form the data is taking? So how do we do that? We can use box plots, the QQ plots, scatter plots. So it can show all these visualization, all these charts can show us. When you have an histogram, you can see if your data is normally distributed. Not if it is normally distributed, it takes a bell shape. Okay. From the box plot, so you can see your mean, your median, see your interquartile range. So to understand just a bit, to have a better understanding of your data and how it's distributed. That's the essence of conducting or doing an exploratory data analysis. Correlation and regression. Yes, this is part of the inferential. It's an inferential statistic. You know, we have different analytics is different from analysis. Analytics is like the main body. You want to look at the data, draw insights from the data, but analysis is the act, just taking that data, examining the data, and bringing results out of data. So analytics is more encompassing than analysis. Analysis is just the act of that. Analysis when you're looking at the test statistics, doing statistical analysis. So in analysis, we have analytics, we have a descriptive, depending this correlation now. You're trying to look at, mean is a descriptive. You're trying to describe your data, okay? The descriptive analytics. For this correlation, you're trying to make meaning like diagnostic analytics, okay? You want to know, are these variables related to one another? So when you now move to regression, it's like you're doing a predictive analysis, saying this variable is dependent on this one, or this causes a change in this can cause a change in this. That is, this one can predict the other. Okay, so let's just move on and try our hands on correlation and a regression on Excel. Okay, yeah, I think that's. Let me put some more slide. So when are you still there? Hello, Benga, are you there?
I'm here.
Oh, okay, all right.
Yeah. Any issues? Hello?
Correlation, do a little bit of correlation. So variables. When we say something is a variable, that means it can change, right? It varies. So we have two kinds of variables. It's either is an independent variable or a dependent variable. What do I mean by independent variable? Independent is like the predictor, okay? What we are measuring, what we have that varies that we think is going to have an effect on another thing. So we call it independent variable, explanatory variable, or predictors. Okay, that's the X. Yes. So the Y now is the dependent variable. What the X predicts. We've said the S is the predictor. So what does it predict? It predicts the Y. Y is dependent on the explanatory. The explanatory are explaining why. Okay. So to do a correlation analysis and a regression in Excel, you have to have this add-in called the analytics pack. So if you don't have it, to get it activated. Can I go on? Okay. Okay. All right.
Go ahead.
So you just, okay, thank you. So when you go to your file, you go to the more and the options, add-ins. So the analysis to pack, then you go and check the analysis to pack. So it gets added in your data tab. So I'm right in the data tab now. Okay, yeah. So this is it right here, data analysis. Let me select my data before I go on. Okay. So correlation, correlation. What does correlation shows us basically? It shows it measures the association between variables, okay? How is this variable related to this variable? And it ranges from -1 to +1. -1, if you have a negative correlation, it means the relationship between this variable is inverse. That is, if one is going up, the other will be coming down, like an inverse relationship. When you have a positive, it's a direct relationship. When this is going up, the other one is going up. They are moving in the same direction. But for inverse, one is moving left, the other is moving right. Okay, let's do a correlation on this. Correlation is related to, say, when you do heat map analysis and you do a heat map, you can, so when you have a when you do a correlation analysis, you can do a conditional formatting on it. So it will look like an heat map so that you can see the variables that are highly correlated. Okay, yes. So this is my correlation matrix now.
Sorry, Mariam.
Yeah, all these are empty. Yeah.
Hello, Mariam. Sorry, you're complaining that your screen is stagnant. So I don't know.
Wow.
Are you doing
Can you
anything
see
on
correlation
the
matrix
Excel?
now?
Please, can you stop sharing and share again?
Okay.
Yes, I think your screen is stagnant because I'm only seeing income happiness.
Wow. Okay. How about now?
It's still coming up. Oh,
Okay.
they've missed a lot. Oh. Your screen has been stagnant since.
Wow.
I'm telling you.
Okay. So let me go a step back.
Okay,
So I
thank you.
was just trying to show how to do a correlation analysis in Excel. Okay. Yeah. Okay. So I said this data, I think you heard when I was explaining the data sets, right? So this data is looking at red wine, the quality of red wine. So we have different variables there, one of which are looking at the acidity, the sugar level, the density, the pH, and the quality of the wine. So the quality of the wine right here is the outcome. Yes, the outcome. Dependent variable is also called outcome. It's outcome variable. So it's what we are interested in, okay? The main thing we are trying to draw our conclusion, where we are trying to bring out points from. We are looking at the quality of the red wine. Okay, so that's the outcome variable. All these are just measures that will take us to the quality. Okay, they are just explaining this quality, which is the outcome. So now I want to run a correlation analysis, looking at how these features, how these variables, these measures are related to the quality of this red wine. So to do that, I said you can, after you've added the heading, so you can select your data before that, and you might not just come to data analysis, correlation, okay? So you're going to input the range of the data. So I've done that already. My data ranges from column A to L. So I have A to L there. Yeah. So I'm telling it that the labels, the first row is not data. It's not a data that is there. It's just labels that are in the first row, so that is able to understand. So I check this. So I want the output to be on a new worksheet. If I want it to be in a new output, probably in the range, in the same sheet, I can come here and select where I want to drop my output. But I want the output to be on a new sheet, okay? I can also choose if I want it to be on a separate workbook. Probably I want my analysis on a separate Excel workbook, so I can choose new workbook. But right now I want it to be on that sheet. So I'm just going to say new worksheet apply, then okay. So saying correlation analysis is like drawing an heat map, okay? So after this correlation matrix, I can do a conditional, have a conditional formatting on it. So I can, because I said earlier that correlation ranges from -1 to 1. Right? So -1 meaning like an inverse relationship, okay? Then 1, a direct relationship, as 1 is increasing, the other 2 is increasing. So when you have from 0.7 upward, that means there's a strong association between those variables. So when you have something less than 0.3, the association is low. When you have from like 0.3 to between 0.3 and 0.5, that's a moderate relationship, moderate association between those variables. So right now, this right here, okay, let's look at, yeah. So this, we have all this right here, blank, because it's the same thing that is going to be here, that will be here, just like a multiplication table. Multiplication table, when you multiply this by this, it's taking like a one-on-one mapping thing, okay? So this zero legacy is saying there's an inverse relationship between, okay, no, let's go to, since quality is our bone of contention, let me just go to quality. Yeah, so fixed acidity and quality, saying 0.12. So there's a direct relationship. That means the acidity of this wine is increasing, the quality too is also increasing. There's a direct relationship, but we don't know what amount of increase in acidity, what amount of it will bring about what measure, yes, what's like a unit change in acidity, what is the change is going to cause in the quality. We don't know that. We just know there exists a positive relationship. As acidity is increasing, quality increases. That is what correlation tells us. Tells us association, whether it's a direct or indirect. Indirect means inverse. Okay. So now let me try to explain. Okay, yeah. Yes, right here, sulfur dioxide. So for free sulfur, saying there's a negative relationship. So that means as sulfur is increasing, the quality of wine will decrease. So for all the ones that have negative here, it's saying as that value, as the value of that variable, that measure is increasing, the quality is reducing. But the ones with positive is saying as the value of that measure is increasing, the quality of that wine too is also increasing. So that is basically how to interpret correlation. So we can look at the ones with strong correlation. Yeah, let's see if I can just do a conditional formatting on this. That okay. So for greater than 0. Okay, let me see, from greater than 0.50. I wanted to give it red field, it's okay. Let me just choose the color scale. So these color scales are always, yes. Let me choose, because green, yes. Yes, I want the ones with red to be the ones with high association. Yeah, let me go for this. Let me see. For this color range. Yeah. So I can quickly spot it right here. The ones with high association, see? pH and fizz acidity. Looking at quality, it is the volatile acidity and quality. Okay. Right. So when you look at correlation, it just tells you the association between two variables. Okay. So you can know if they are related or not. So let's try our hands on regression. We are going to go to the same data analysis, adding. So go to your data tab, data analysis. So right now I want to do a regression. There are different types of regression, but what we are doing here is the linear regression, and there are some assumptions that need to be met before you can do a linear regression. Linear regression assumes that your data is normally distributed. Okay, so you have to draw an histogram, look at your data, the bell shape, if you have outliers, if it is due to input errors, or if there's something that can do an imputation where you remove the outliers and you mean imputation and replace it with the mean average of all the other outcomes in that variable. So right now, we're going to input our y range. Y is the outcome, like I explained earlier. So for regression, we have simple linear regression and multiple linear regression. Simple is when you have just one explanatory variable, just one measure, okay? Multiple is when you have more than one, you have two or more. So to input the y range, for x range, let me look at my correlation variables. I can just choose, I want to choose the variable that is highly associated. Okay, let me close this window first. I want to do a simple linear regression first before we do. Okay. Yeah. Okay. So let me look at the volatile acidity first. Seems to be the one with my association. Okay. Oh, okay. This formatting was done looking at the negative and the positive values. See, this 0.47 right here. The continuous formatting can be changed, but this, okay, since I've spotted this, let me just go on because we don't really have time. So there's alcohol. Yes. Check for alcohol and the quality. Okay. So analysis, regression. Okay. My Y range is the quality. Shift control and arrow button. Then my X, that's what I want to do. I want the explanatory variable to be alcohol. Oh, I think let me include the labels. I want to go to select it again. Yeah, include the labels. I want it to show the confidence level. Okay. So the output should be on a new worksheet. And I'll press OK. Yeah. So this is the output of a simple linear regression. The multiple R that you see here is the test of association, like correlation. If we go back to the correlation material we had earlier, you see that it's the same thing with it. So you say right here, 0.4761. 0.4761. So the multiple R, the first output, the first table you're going to get in the output of a linear regression, the multiple R is the correlation between that variable and your dependent variable. So this R square is looking at the fit, the accuracy of your model. Okay. So when you are doing a multiple linear regression, when you have more than one independent variable, we usually look at this adjusted, but it's always in line with each other. We look at this adjusted R square, but when it's a simple linear regression, we can use this R square. So for this, it's saying 22. Okay, that is approximately like 23% of the variance. 23% of the variance in that quality is due to alcohol. Okay, that is the variability in the quality of this wine is because of the alcohol, the change in alcohol. Is the change in alcohol that is bringing about the variance in the number, the variance in the quality of this wine. Okay, so that it is amounting to only 23% of the variation can be attributed to alcohol. Am I making sense? Are you guys getting what I'm trying to explain?
Please go ahead.
All right, okay. So now the standard error here is giving you like the deviation from the true mean. Okay, there's no way, nothing is perfect. Even when you sample, I forgot to mention something called sampling error. Okay, sampling error is like the value between your observed and the true population, the difference. That's the standard error. Okay, it's always an estimate that we are trying to get. We don't have that true value. We're just going to have an estimate of that parameter. Okay, so this standard error, the lower the better. Okay, okay, yeah. So the output is going to give you ANOVA also. Yes, it's going to give you ANOVA. So we have the sum of square regression, sum of square residual, the degree of freedom. Basically, what we need in this output is linear regression is going to plot. It's like plotting it after drawing. You can use your hand, so you can do a linear regression manually. Okay, that is where we'll use those is I will plot the graph and choose the line of best fit and draw a line and find the gradients, right? That gradient, the slope. That's what, so linear regression is like, this is, let me write the equation here. Because like B naught should have included this in my, it's going to be beta, not regular P. So it's a beta naught plus a beta 1. Let me input that. Insert symbol. Yeah, beta. Beta. Okay, I insert. Yeah, okay. Subscript. So a beta naught plus okay, back to be a subscript again. Beta 1 okay. Yeah. Plus, yeah, that place. Wow. It's covering my screen. Okay, so x1 subscript again. I'm just trying to write the linear regression equation. Okay. See, then we have, why am I coming faster here? Okay, plus the error term. Let me just use one E to denote it, okay? Just don't want it to be a regular E. Okay. So the B here is the intercept, okay? This B is saying if X is not there, what is the variability in Y? That is the variability that happens in Y that is not attributed to any explanatory variable, okay? That is what the B naught is saying. So the B1 right here is the slope, the gradient, okay? We all know that gradients that we do calculate whenever we draw a graph, okay? So right here, this is our beta naught. That is the intercept. 1 point. So our equation is going to look something like this. Y equals 1.87 plus our beta 1, which is 0.36 x1 I'm just going to leave my one like that since, okay. Then the error term, that's the standard error of this estimate, okay? 0.16 0.0017 or so, plus or minus. So it's saying, standard error is saying the deviation, okay? The possibility that this estimate is a little bit, it can be higher. It can be an addition of 0.0166 or an addition of, or a subtraction of 0.0166. So it's like a plus or minus, it's a deviation, okay? It's either going to reduce by this number or it's going to increase by this number. Like I said earlier, we cannot have the true, we just have to get an estimate that move close to the true population parameter. We are not going to say this is how it is. It's not a rigid thing. Statistics. So that is why we have confidence interval so that your estimates will fall within this range. So when you have, yes, this is our confidence interval here. Confidence interval and p-value, they both interpret to the same thing. When you set your significance level, what's a significance level? It means the probability that when you conduct this, when you do this hypothesis and you test it, the probability that the variability you are going to get is not due to chance. So when your probability that it is not due to chance is very low, is less than 0.05. So that means what you have there, what the variability that you have discovered, it is due to the measure that you have put in. It is not due to chance. So you say it is statistically significant. So whenever hypothesis testing, you have two hypotheses. What is hypothesis? You have like a prejudice, okay? You have something that you want to test. You have a knowledge, but you now want to know, is this knowledge, is it confirmed? You want to test, is it true or is otherwise? So your null is always, when you say no, is always a negation. No, that this thing is not correct. So alternative is saying, affirming it, oh, this is correct. So for this, the null hypothesis for this is saying that our B1, that this intercept, this, what's it called? This correlation coefficient of the explanation variable, that it is 0, it's having no impact. That is what the null is saying, that the variability in Y is not due to X. Or alternative hypothesis is saying otherwise, it's saying the variability in Y is due to the, okay, let me not use Y and X now. The variability in quality, that what if quality changes from 30 to 32, or if it reduces, it goes from 30 and 28, is because of the level of the alcohol that is in the wine. Okay, that is what the alternative hypothesis is saying. But the null hypothesis is saying, even if this is the changes in this is not causing anything in the Y. So that is why you have to do a statistical test. Okay. So one of the statistical tests is the linear regression we are trying to carry out now. So let's just interpret this together so we can get a better understanding. We can interpret using the p-value. Like I said, if the p-value is less than 0.05, it is statistically significant. So you reject your null hypothesis. And you do not reject. We don't say accept. So it's either you reject or you do not reject. So when you reject your H0, that is the null hypothesis, you now conclude that the variability in this is due to the input. The explanatory variable is given it. Okay. So right now, this. So you can look at the confidence interval too. Since we are saying our null is saying P1 is 0, that is having no input in it. So when you look at the confidence interval, your confidence interval must not include 0. What does confidence interval means? It's saying this estimate that I have right here, this 0.36, it's just like an estimate close to the main population parameter, like I explained earlier. So it's saying it can, that's why we have a standard error. It's saying it can increase and it can reduce, there's a deviation. So all the possible values that it can take, this is it. These estimates can be from 0.328 up to 0.39. So these estimates can increase up to this point and it can reduce up to this 0.32. Okay. So when your interval, your confidence interval consists of 0, if the interval includes a 0, so that means it's already saying the H0 is true. So that, I don't know. Okay, let me try to explain this better. So what I'm saying is, when you have a confidence interval, okay, you know, we said confidence is like I explained probability earlier. When you have a set of, you have all possible outcomes, okay, and you're picking from it. So it's like, this is like a pick of all the possible outcome. The sample space is this, okay, but we pick this out of it because it's one occurrence out of this. So everything in between 0.3, this number right here, this is the lower bound and this is the higher bound. So all numbers that exist between this interval is possible to be the coefficient of this outcome. That is what this is saying. So when this range includes a 0, it's saying that these coefficients can be 0. So if it says it can be 0, it's already certifying that H0 is true. So we don't have any reason to reject H0. So we are going to say what we found here is due to chance. It's not because of the variability. It's not because of the influence of the explanatory variable. Time is up. So yeah. So we can look at, whenever we are interpreting, we can look at our p-value and we can look at the confidence interval to interpret our linear regression. Like I explained earlier, the first table, you're going to get your correlation coefficient here. Then the R-square looks at the accuracy of your model. How well is the variability in your model due to the explanatory variable that you have included in it? Okay, then standard error measures like the deviation of your estimates from the true value. So I think if we have any question regarding linear regression, Mr. Wenger, any question? Hello?
No questions. I think we'll go and watch the video.
All right.
I think Paul is raising up his hand. Paul.
Is on go. Yeah.
Thank you so much for the section, ma. I learned a lot. So I want to ask, is it under the circumstances we always do reject the null hypothesis? Is it under these circumstances what you did tonight?
Yeah, you are going to look at your p-value and
Okay,
your confidence interval. That's what will infer your conclusion.
exactly. Because I remember like we have to do our H1 and H0.
Yes, H0 and H1, yes.
Thank you.
Thank you for joining. Yeah, Winger, I think that's all right.
So are we done with the class?